All right. So Tito, you said you wanted to do the first one. What does it mean for a function to be 1-to-1?
Every x section only has one y.
Every x, which is an input value, has only one y. I'm going to change that to the word one because I'm afraid that's going to get confusing there. So I'm going to change that to the word. Only one y, which is an output. There's a little bit more to the definition. What you've got is absolutely correct so far. So I'm going to put an and here, because that first part, this is just what it takes to be a function. So how do we take it that last step?
From only one x input?
Yes, every y comes from only one x. Wonderful. And guys, if you have earbuds in, if you have music on, I need you to take those out and turn that off. I know it can make the morning much nicer. While we're working on the bell work during that 5 minutes after the initial bell, I don't mind if you have something in your ears while you're working. But once we actually start talking about class, I need you to take them out and turn them off. Not the least of which reasons is I can hear it and it gets really distracting for me. Yep, like that.
They're not.
No, it's fine. I just, a lot of times I can hear like just enough that it distracts me. And so that's one of the biggest reasons why I ask once I'm actually talking, if you guys have those turned off for me. All right, number 2, we had 4 parts to number 2, and it says use what to evaluate?
Order of operations.
Order of operations. What is order of operations? PEMDAS. Parentheses first, if they're there and you can simplify. Then exponents. Then you do multiplication and division in the same step, whichever you see first as you move left to right. And finally, you would do any addition or subtraction. Again, as you see it, whichever comes first, left to right. We are simplifying on these. We're not trying to get a variable alone. We're just going to perform operations on the numbers that we're looking at. So on part A, what's the first thing I would want to do here? Multiply. We're going to multiply the 8 and the 12 together first. So I'm going to recopy everything else. I would have 24 minus what? What is 8 times 12? 96 divided by 4. What do I do after that? Divide. We're going to divide 96 by 4. What is 96 divided by 4? 24. Then I get to the subtraction, and how does this evaluate? What is 24 minus 24? 0. This one evaluates to 0. Part B and part C are very, very similar, except for one key difference. What's the difference between part B and part C? One's inside parentheses and the other one isn't. This actually makes a big difference when we're talking about order of operations. Because technically, in part B, this minus out in front means I'm taking -1 and multiplying it by 2 squared. Negative and then 2 squared means that I am multiplying a -1 to a 2 squared. Order of operations says I do which thing first, exponents or multiplication? Exponents come first. So I would do 2 squared first, which would give me what? 4. And then I multiply it by the -1, and I get -4. This is why if you don't put parentheses in your calculator, when you go to square a negative number, it'll give you a negative answer. This is what your calculator is doing. The notation is really important when you write it down for yourself, because that usually determines how we put it into our calculators. And if you put -2 with a squared with no parentheses, that is the order that your calculator will evaluate it in. The next one down, we've got the parentheses before the squared on the outside. What does it mean for something to be squared?
To be multiplied from itself.
Multiply it by itself. So this time I'm not doing 2 times 2 and then multiplying it by a -1. What am I multiplying by itself? -2 times another -2, because it's inside the parentheses. And we know that a negative times a negative will give us what? A positive. So when I use the parentheses, I get what I would expect, which is +4. When I don't use the parentheses, we end up with a negative number, because order of operations has us doing the squaring before making things negative, because that's multiplication. Last one, part D. First thing I want to do. Parentheses. So 2 plus 6 would give me what? 8. So I have 16 divided by 8 times 10.
Multiplication next was going to be 16 divided by 8.
You do the division first.
No.
You
Do the division.
divided by 8.
Really?
Why?
'Cause
You're correct.
you left the division.
Yes, multiplication and division happen in the same step. Remember, they're inverses of each other. It's basically one operation. They undo each other, but overall they do the same type of thing. And so multiplication and division, this is why when I write order of operations, I don't write PEMDAS as a word that just goes straight down or straight across. I write the P and the E because those are each individual steps. And then I put the M and the D side by side, because we do them all in one step, whichever I see first as I move across the equation, or in this case, the expression from left to right. So as I move from left to right, I run into the division first. 16 divided by 8 would give me 2, so I have 2 times 10, which would evaluate to what? 20. Beautiful. And then the last one on the bell work today, it said evaluate for b squared minus 4ac if a is -3, b is -2, and c is 6. And I've got all this beautiful wide open space over here off to the side. So I'm going to do my work over here because it's really hard to see at the bottom of the screen, but you guys can see over there a little bit easier, right? Okay. So we want to substitute into b squared minus 4ac. What am I putting in for b? -2. Should I put parentheses around that?
Yeah.
Yes. -2, and then we're going to square it, because we just saw in the previous problem that whether or not those parentheses are there is really important. -4 times, what are we putting in for a? -3. And then c, what are we putting in there? +6, yes. And then just like the previous problem, we're going to do order of operations. So I'm going to do my exponents first. I hope that didn't break.
I hope it didn't either.
-2 squared would give me what? +4 minus 4 times -3 times 6. Then we're going to multiply whichever one we see first going left to right. So that's going to be this right here. I have a -4 being multiplied to a -3. Negative times a negative means what? Positive. So I have plus 12 times 6. Then I would do this multiplication here.
72.
4 plus 72. And 4 plus 72 would give me what?
76.
76. Beautiful.
I like those questions. Are there going to be a lot of those on the test? Please say yes.
There will be questions like that on the test.
Perfect.
Because what we just found there, that's the discriminant. When we do b squared minus 4ac, that is the discriminant.
I can deal with that way better than I can deal with it.
Wait, do you know like when our upcoming test is
Mm-hmm.
gonna be?
Yep, your next test is going to be next Thursday, the 30th. This is a very, very, very short unit.
Over what we're learning right now.
Yes. We'll be done by Friday this week with this new material, because this test is going to be your midterm. So everything we covered in Unit 1, everything we covered in Unit 2, and everything we're learning here. So I wanted to make sure this wasn't a huge unit to be able to be going over all of that stuff. It will be. Yes.
Is there going to be any
Fall break is, I think it's the 3rd week of October. Wherever October 20th is, that week is our fall break week.
1 week?
We get 1 week of full break, yes.
Yes.
Hey, last year we only got 2 days, so I'm good with a week.
The only one that
Yeah.
gets 2 weeks is one today.
Yeah. Go ahead and open up your books to page 114 for me. We're going to keep talking about one-to-one functions today.
What was it?
114, yes.
Are you going to have extra credit assignments for the midterm because?
We'll talk about that a little further. Let's get through some of the material first, and then we'll talk about the midterm. All right. I want to know whether these represent a one-to-one function. And then we're going to write down the domain and the range of the inverse. We talked briefly about an inverse yesterday, just like what an inverse is. Today we're going to talk about how to take a table and write an inverse rule from a table. So on this first table here, did we decide yesterday this was or was not a one-to-one function?
It's not.
It's not. We have 2 of the same input, but it goes to 2 different outputs. So no, because it is not a function. Yesterday when I talked about inverse, we said an inverse undoes something that's been done. So like division is the inverse of which operation? Multiplication. Addition is the inverse of which operation? Subtraction. In this case, we're going to be writing a table that would undo what this table does. This word inverse, I want you to like ingrain in your brain this synonym for it. Inverse means to switch your x's and your y's, your input and your output. So for this table right here, if I wanted the inverse table, I'm going to take my x's and y's and I'm going to switch them. So down the left-hand column, I would have 1, 2, 3, and 4. What would be down the right-hand column? 5, 5, 10, and 15. Domain means I'm looking at my x's. And when I have a table like this, I don't have a function rule. My domain is going to be all possible x's. So every x that's written down here is my domain. I'm going to put it inside curly brackets. 1, 2, 3, and 4. Your range is all the possible y values. So I'm looking at the y column here. I don't need to write down numbers that repeat themselves. I only need to include each number that's in that list, but I don't need to write down numbers that show up more than once. So my range would be 5, 10, and 15. I don't need to write 5 and 5 because I already have 5 on that list.
You hear that?
I did hear that.
Tuberculosis.
Second table. Was this one 1 to 1?
Yes.
Yes.
Every one of them has one.
Every x has one y, and every y has only one x. I'm going to make the table for the inverse now here too. Let's do that one in, I'll do it in this blue color. No. What'd you say, dear? 4, 8, 12, 16, yes. So I'm going to make the table for the inverse so that I can actually see it. Four, 8, 12, 16 would be my new x's, my new inputs. What about the outputs for the inverse?
1, 2, 3, and 4.
1, 2, 3, and 4. Remember, inverse means to switch. These two are going to trade places. When I'm talking about input and output, x's and y's, the left column is always my x column. It's always my input column. The right column is always my y column, my output column. When we have labels above the top, not just x and y, but it's telling me what those numbers are, then I would switch the labels as well. We'll look at an example of that later today. But I just want to make sure that we know the left column is always the x, always the input. The right column is always the y, always the output. Last table, was this one 1 to 1?
No.
No, why not?
Because every x does not only have one y.
Close.
Every y doesn't have.
Yeah, every x has one y. That is true. Every x goes to one y value. There's no x's on that table that go to 2 different y values like on that first table. Yep, that's okay. Every x does go to one y, but we have y values that go to more than one x. So if I'm looking at this like that first table, here's my problem.
5.
5 came from all these different x's. All right, domain of the inverse. What would the inverse for this look like? 5. And that's it. That's the only number in the domain. What would my range be? 1, 2, and 3. Beautiful. All right. Looking down at the bottom of the page, there's some different visual representations of relationships. We can take these different representations and put them in a table if we want to, or we can look at them like this right here. I want to make sure that every x has only one y to see if it is a one-to-one function. So look at the x's. Do any of my x values repeat?
Yes.
Which one? 3 repeats. So I have the same x value, different y's. So is it a function? No. If you have the same x, but each time it sends you to a different y value, it is not a function. Same x goes to different y values. Is the inverse a function? When we had our table, we were switching the x and y columns. If I have a list of ordered pairs, we are going to switch the x and the y in each ordered pair. So for my inverse, my first ordered pair is 3, 2, so I want to switch those numbers around. So what would that be? 2, 3. What would the inverse of my next ordered pair be? Negative 1, 1. Third ordered pair? Negative 4, 2. Next ordered pair? Negative 9, 3. And the last one? Negative 16 and 4. So there's my inverse relationship. I want to know whether or not that is a function. So now we're going to look at all of our new x's. So I have 2, negative 1, negative 4, negative 9, and negative 16. Do any of our x's repeat? No. So as far as we know, every x goes to only one y. So the inverse would be every x goes to only one y. This guy over here on the right, first of all, it's real fuzzy on my page, and I apologize if it's fuzzy on yours as well. This is called a relation map. It kind of works like a table does, except I can really see if there's any x's that go to more than one y value. Because I've got these arrows showing me what values they go to. Are there any of the x's that as you follow off the end of it, it points to two different y values? No. There are several x's that send you to the same y, but every x has only one arrow coming off of it. And so this would be a function. Is it a one-to-one function? No. Why not?
Because it only doesn't have one y.
Yeah. Every x has only one arrow coming off of it. It's only pointing at one y value. But when I go over and I look at the y's, there are the ends of many arrows pointing at each of these. So every y didn't come from only one x. So every x has only one y, but the y's came from more than one x. I'm going to take this relation map and I'm going to flip it around to make the inverse. What word did I tell you to think of when I say inverse?
Reverse.
Switch or reverse. Yes, that'd be fine. We are going to switch our x's and our y's. So now I have this first bubble, and what's inside it?
1 is equal to 0, 1.
Yep, 0 and 1.
It's not a function.
Tell me why not.
Because it goes to, the x's go to multiple y's.
That's correct.
That's why.
We would have this going to 2 and to 4, that's enough right there to break it. But then 1 goes to 1, goes to 3, goes to 5. So the inverse is not a function. The x's go to more than 1y. All right, we're going to switch the page over to 115. We're going to look at these graphs and determine whether or not they are one-to-one functions. When I'm looking at graphs, what should I use to help me determine whether it's a function and then whether or not it's one-to-one? Does anybody remember? So to check for a function, yep, we're going to use the vertical line test. Then to check to see if it is one-to-one, I use a similar test, but it's not vertical. What do I do to check once I know it's a function to see if it's one-to-one? Not a vertical line, but I would use a horizontal line test. So on this first graph, I take my vertical line, so my pencil. Anywhere I move it along this graph, would it ever cross my vertical line in more than one spot? No matter where I put this, does it cross my vertical line in more than one spot? No, not at the same time. So it passes the vertical line test. And I get lazy. I write VLT for vertical line test because vertical line test is a lot of letters.
Yeah.
To see if it's one-to-one, I'm going to turn my pencil the other way. Only if it passes this do I turn my pencil this way. Horizontal line now. If I run a horizontal line across this graph, does it cross my horizontal line in more than one spot at a time? No. So it passes the horizontal line test, HLT. Does that mean it is or is not one-to-one? It is. If it passes both tests, it's one-to-one. Next graph over, I have a parabola here. Vertical line test first to see if it's a function. Anywhere I take a vertical line across this parabola, would it cross my vertical line in more than one spot at a time?
Yes.
Where?
Vertical?
Vertical.
No.
Vertical line test, it passes. Then I'm going to change to horizontal. Only if it passes the vertical do I check horizontal. Does it pass the horizontal line test?
No.
No, because when I run a horizontal line across this, in almost every place except right at the vertex, it's going to cross more than once. So this fails the horizontal line test. So I would say, no, it is not one-to-one because of this. Last graph over here, and then we're going to look at the table at the bottom. Does this graph pass my my vertical line test? Because I always do vertical first.
Yeah.
Yes, it passes my vertical line test. Then I turn my pencil the other way, and I check for horizontal. Does it pass the horizontal line test?
Yeah.
Yes. Is this a one-to-one function?
Yes.
Yes. All right. Let's look at the table at the bottom. We're going to revisit some Algebra 1 stuff and see what we remember. And then we're going to talk about inverses there too. I want to start off with writing an equation for this table in slope-intercept form. What is slope-intercept form? Y equals mx plus b. What does the b stand for? Close. Not baseline. But that's a great way of thinking about it. This is our y-intercept, which is our starting amount. So you could kind of think of it like a baseline, because a baseline is a starting position. What does the m stand for? The slope. Slope is your rate of change. Rate of change. The way we find the rate of change, I want the change in the y values divided by the change in the x values. That little triangle in front just means change in. So change in y divided by change in x. So I'm going to look at this table here. I'm going to look down the y side first. How much are the y's changing by each time? 2. How much are the y's changing by, going up or down by? They're increasing by 2 each time, right? Look down the x side. How much are the x's changing by each time? 2. Up or down? Up. Getting bigger by 2 each time. So when I think about the change in my y values, you said those were going up by 2 each time. Change in my x values, those are also going up by 2 each time. So what would that make my slope? 1. 2 divided by 2 gives me 1. Here's my slope. And then I just need to find the y-intercept. What do I know about every y-intercept when I think about those ordered pairs? X is 0, yes. X is 0, and the y value can change there, correct? Yes? No?
Yes.
Yes. Okay. So I'm going to take what we've got so far. We have y equals 1x plus b. I'm going to grab an ordered pair off the table, and I'm going to substitute it in for x and y, and we're going to use that to find b.
2 and 8.
You said 2 and 8? Sounds good. Which part do I put in for the y? 8 equals 1, and then I'm going to put the 2 in the place of x plus b. What is 1 times 2? 2. So I have 8 equals 2 plus b. What would I need to do to get the b all by itself now? Subtract the 2 from both sides. So what is our b value then? 6. I now have all the pieces that I need to write this equation in slope-intercept form. So I'm going to shrink this down just a little bit. There we go. What would my slope-intercept form look like then? I know it has to start with y equals. What did we say our slope was? 1. Slope is the letter m, but it's being, like in this case, it's the number 1. So I would have 1x plus, what did we say b was? 6. When your slope is 1, because it's being multiplied to the x, you don't have to write that. So there's my function rule. What is the meaning of the slope in this situation? So what are the y values telling me about?
The hair length.
Hair length. change in y would be change in hair length divided by the change in x. What is x telling us about?
The amount of months.
Months. So change in months. Did we say our slope was positive or negative?
Positive.
Positive. So my slope means an increase, because it's positive, of 1 inch hair length each month. It's always going to be an increase or a decrease in whatever your y is telling you about for each whatever your x is telling you about. The meaning of the y-intercept, we said our y-intercept was 6. So that ordered pair would be 0, 6. What did we say x was telling us about again?
The months.
The months, yep. And what's the y telling us about?
The
Hair
hair length.
length. So the hair started at, because 0 months would be the beginning, 6 inches long. Hair started at 6 inches long. All right, then they want me to create a table for the inverse. Inverse means to do what again?
Reverse.
Reverse. We are going to switch the input and the output. So what should go down this column over here on the left?
8, 10, 12, 14.
8, 10, 12, and 14. And 8, 10, 12, and 14 are all numbers that are telling me about what? Are those months? That's hair length. So this is now my input over here, but these numbers are still telling me about hair length. Down the output side, yes, this would be my months, and you're absolutely correct. 2, 4, 6, and 8. Absolutely. So it said to include labels. We've included our labels. I need to know what all those numbers mean, but when they switch sides of the table, I'm switching the input and the output. I'm not switching what those numbers are telling me about. Does that make sense? Okay. Your first homework assignment is due tomorrow. Homework 1 for Unit 3, due tomorrow.